So welcome everyone to our lunch panel. And the topic of this panel today is the future of SystemC. Now, let me ask you, the audience, how many of you are users of SystemC? Okay, that's a start. That's a number more than zero. But as Lou indicated, Accellera has many different activities under its umbrella and lots of standards that it has worked on and developed and is actively engaged with improving over the years. SystemC is certainly one of them, but not the only one. And judging from the response just now and the relatively fewer hands that were raised, it's not the most popular standard among the audience that we have here today. So we have assembled a panel here, a very illustrious panel with representatives from both the user side and the EDA vendor side to help us explore what the current state of SystemC is and what the future holds for SystemC and what the future should hold for SystemC. So we're going to have each of our panelists give a short positioning statement, introduce himself, give a short positioning statement about what his relationship is to SystemC and the initiative that has been part of, well, I think it became an IEEE standard more than 13 years ago, I believe, so it's been around quite a while. So what each person's relationship is to SystemC and what he thinks the future holds for this standard. So why don't we start with right here on the right and go down the row.
Martin Barnasconi, NXP Semiconductors. I'm technical director in the department which is in charge of the system design and verification methodologies. So we are responsible to roll out design flows and design methods, especially focusing at the higher levels of abstraction to NXP businesses worldwide. So my relation to SystemC is that I am the initiator of the SystemC AMS extension, so the mixed signal extension to SystemC. So similar that there are extensions, AMS extensions to Verilog, there is also a need for AMS extensions at the system level, because how can you make a virtual prototype of a chip where you have also analog or RF front ends and IP in that same product. And at the end, you then also need to model that at a higher level of abstraction. So I started SystemC AMS standardization more than 10 years ago in the Open SystemC initiative, which was at some point merged with Accellera. And a couple of years later, I was asked to drive the technical standardization coordination within Accellera. So I'm also in charge of the technical working groups where I work with basically all SystemC teams to build and enrich the SystemC ecosystem. So SystemC main language, configuration control with CCI, synthesis. There are quite some different flavors or extensions of SystemC, and that all needs to work nicely together. So I'm also coordinating that together with the leadership teams in those various teams. So my position statement is that SystemC is already there for a long while. I see that depending where you live on this planet, you might be more or less exposed to SystemC. But a general observation I have is that in the last decade, quite some standardization and developments have been done at the right side of the V model. So focusing on integration and verification. However, there are also needs and activities, so-called shift left. You might have heard about that. However, that means that we also need to further develop the ecosystem at the left side of the V model. So how do we do top-down design? How we bring modeling into the picture? And I think SystemC is a key role. So my positioning statement for today is, if we like to shift left, we also should focus on SystemC at the left side of the V model.
Thank you, Martin.
My name is Mark Glasser. I'm a principal verification architect at NVIDIA. I've been involved with SystemC for a long time, initially in the early days as a tool developer working for EDA companies, and most recently in the last few years as a user of SystemC and building models and building methodologies around those models. I think there's a lot of headroom for SystemC to grow in the industry in many different directions. Of course, in the classic direction of ESL and using it for building high-level models, but also in the areas of verification and HLS and mixed signal. I think there's lots of places for those to grow. I think the key to the whole thing is connecting all this stuff together. So for SystemC to gain more traction and see more hands raised next time that question is asked about who's using the tool, SystemC needs to have more deeper connections into existing tool flows, particularly into RTL flows. And I think that's kind of the direction that the standards committee needs to move to connect all this stuff together and be able to build flows where you can easily move between different abstraction levels and make that all fit together nice and neat.
Thank you very much, Mark.
Okay, good morning. Thanks all for joining. My name is Filip Thoen. I'm currently a scientist at Synopsys, looking after one of our key SystemC products, Virtualizer, which is really positioned to deal with pre-silicon software development. I started my engagement with virtual prototyping. It's kind of scary to believe, but in 1999, when I was co-founder of NVIDIA Corporation, which was one of the leading early companies doing virtual prototyping, and I joined Synopsys in 2006 after we got acquired. But yeah, it's been taking 20 years, but I think the good news at least is I think SystemC has nicely moved into that area of what I call system modeling. I think if you historically look back at kind of the early attempts of SystemC, I think it was kind of positioned a little bit as verification, but I think it was trying to do too many things what Verilog was doing, and because of that, I think it was mostly not successful. There was too much overlap. I think what happened with SystemC over the years, and I think, as I said, it takes 20 years for new languages and new methodologies to get adopted. I think it nicely became kind of the fueling technology and language to enable the shift-left motion, mostly in software development as well as in architecture analysis. And I think the standardization which happened around SystemC as well as TLM2 are, I think, very big drivers enabling this kind of new pickup of this technology. But I kind of want to echo at the same time what Mark was saying. These flows have to be connected into the rest of the design flow. And I think one of the two things we're working on very hard right now at Synopsys is connecting these flows, mostly software development and architecture analysis across the design flows, spanning into things like emulation, spanning into things like prototyping, and allowing that seamless transition to go across. But kind of echoing as well as what Mark was saying is I think specifically, on the verification side, I think we have some ways to go of connecting these flows. And I always challenge customers who may be a little bit new or just became a user of SystemC, think about what you can do as extras with SystemC. And I think that realm of opening up more capabilities in verification, I think, is definitely an opportunity, which I think is a little bit untapped. And we kind of internally use the term model first. So use the SystemC model first and use that later on to drive your verification flows. I think that's definitely an untapped opportunity. I think these flows cannot just be blue pies in the skies. They have to be connected to the flows. I think probably midterm and longer term, what we see happening is that we see a lot of pickup of SystemC and system modeling more into system companies now as well. And I think automotive is definitely one of the areas where we see a lot of growth. I think SystemC has been kind of deployed in IP vendors and semiconductor customers. And I think a lot of the standardization have been driven by these requirements. Of course, once you start fueling an ecosystem, and of course we have some experience with that through some of the other products we have in that market, there's other requirements which for sure will pop up, things like protection, encryption, and things like that. So I think that's an area where SystemC can definitely play a big role. And of course, if you look at automotive, it's all about virtualizing the design flow. It's very interesting. A lot of new interesting developments are kind of driving, and will drive the need for SystemC.
Thank you very much, Philip. Mike?
Hi, I'm Mike Meredith. I work in the high-level synthesis group at Cadence. Our high-level synthesis tool takes SystemC as its input, so that's obviously super important to us. In terms of my relationship with SystemC, well, I've been working on high-level synthesis with SystemC since about 2000, so a year or two. I assure you that my wife does not understand my relationship with SystemC in the least. But in order to talk about the future of SystemC, I think I have to look back a bit at the past of it, where, as has been mentioned before, the initial adoption was largely for system, virtual platform, that kind of very abstract modeling. And well, it's SystemC, so That's natural. We have seen a great uptick in adoption of SystemC as an implementation language using high-level synthesis. And that has driven other uses as we see people using SystemC as an alternative way to create RTL for new designs. They need a way to verify that behavioral SystemC model as well as verifying the underlying or resulting RTL. And so we see more SystemC being used for verification uses as well. And that, I think, as those two things extend, I think we'll see more and more of that. We've had some standards for verification and for synthesis for some time. And in the last year, I think the second draft of the UVM SystemC draft was put out, and I have seen users picking that up and using that in production projects. I have informed them that they're painting outside the lines a little bit. This is a draft, but they know what they're doing, and are seeing value from that even at this early stage of its standardization.
Thank you very much, Mike.
Hi, my name is Stuart Swan, and I'm a technical marketing engineer at Mentor, working on SystemC capabilities within Catapult, high-level synthesis, and related tools. Prior to Mentor, I spent 4 years at Qualcomm working on SystemC virtual platforms and high-level synthesis usage for next-generation wireless chips. And prior to that, I spent many years at Cadence working on SystemC and System Verilog tools, virtual platforms, and so forth. I actually have been involved in SystemC as long as this guy here. I started at around 2000, so we've known each other a long time. And I was worked on the. I'm not your wife either.
He understands it.
I actually worked on the original SystemC 2.0 release in around 2000, and I was the technical working group chair for the IEEE 2005 SystemC LRM. Participated in writing the first book on SystemC. And I also worked on System Verilog OVM and UVM. And an interesting thing we were just talking about is actually OVM and UVM stole a lot of stuff from SystemC. And if you
Creatively used.
Yeah, there's a lot of concepts and classes and so forth that were kind of just brought right over into OVM and UVM. So anyway, so my thoughts on where SystemC is and where it's going. I think, if you look way back over 20 years ago, the industry very quickly made a transition from gate level to RTL level design. And people were kind of thinking, well, within the next 5 or 10 years, it would also make a pretty quick transition from the RTL level to the behavioral level. And that didn't really happen. And I still run into people today who think there's really nothing happening, right? There is no transition occurring. And my experience, based on interactions I've had with customers and also my experience at Qualcomm, is that there is a transition happening today for certain segments of designers. And the people that are making a transition to a higher level today are doing it because of some specific catalyst. And the examples of those types of catalysts that I see are algorithmic complexity. So if you have customers that are doing very complex designs like 5G wireless, or computer vision, or video compression, things like this, the algorithmic complexity is just pretty unmanageable at the RTL level. Also, they're making a change to a higher level because they need to go to a higher level of abstraction because of changing specifications or standards. Another key motivator for changing is because they recognize the risk in doing these very complex designs, and they want to push some of that risky or complex functionality into software. So the minute you take this big chunk of functionality and you push it into software, now you need to verify the interaction between the software and the hardware. And you really need to do this very early in the design process. You may need to sort of fine-tune the partitioning between the software and the hardware. And then finally, a major motivator is just the time to market pressures that a lot of customers are facing. In terms of what we need from Accellera to spur SystemC adoption, I think that actually the standards we have are in very good shape. They're very high quality, they're very accurate. I think that there's some building blocks that we could layer on top of the existing standards. Things like interconnect libraries that are synthesizable and interoperable with the TL2 virtual platform, things for modeling on-chip buses that are synthesizable, banked memories. These are basic interconnect components that are found on almost any SoC. And if you are intending to synthesize the system level specification into hardware, pretty much anybody needs this. And last thing is, what do industry groups need to adopt a SystemC? Well, as I mentioned, I think they need a catalyst. If a design team is successful with the RTL design methodology today, and they don't have a real need to change, they're not going to. But if they have one of those factors that come into play along the lines of what I've mentioned, I think they will change. The other thing that I've noticed is design groups have a real hard time doing this on their own. They usually need to bring some sort of expertise in from the outside, be it a consultant or an EA company or somebody who's already had experience with these types of flows to get the basic infrastructure up and running. And once that's up and running, then they can take it there on their own. Thanks.
Thank you, Stuart. So we're going to get the ball rolling and throw out a few questions to our panelists. But if the audience has questions at any point, there are microphones in the aisles on either side of the room, and you are welcome to queue up. And when we see you have a question, we'll help you have an opportunity to ask it. But in the meantime, one of the things that came up in the conversation that the panelists had in preparing for this panel was that it's kind of commonly accepted that SystemC has been more widely adopted outside of the U.S. than within the U.S., and especially in Europe. So what is it that the folks on the other side of the pond know about SystemC? What are the benefits that they're seeing? What could we be taking away from their experience to help us use SystemC more effectively in the U.S.? Panelists?
I'm in Europe, so probably I should answer this first. What I see in Europe is that we try to somehow find the right balance. So what we should develop at Europe mainland and what do we get from instance from countries in US when it comes to EDA tools. And to be honest, sometimes we are not always happy with the tools we get from the US, so we have to do our own things. So there are quite some European projects out there which look into next generation methodologies, next generation design flows, because we see that the type of products we like to develop are either complex, mixed signal, heterogeneous, hardware-software co-design. So there is a lot of partnership within Europe between companies, especially in automotive domain, but also between the universities and the industry to really often question the quality of our design flow, the quality of our way of working, and is there something to improve. And we identified already somewhere between 2000 and 2005 that there is a nice opportunity with SystemC to use that as an integral part of the design and modeling ecosystem. And with that, we evaluated and evolved with universities and companies within Europe, which to some extent is a bit independent what happened here in the US. So I would say automotive as a main driver, mixed signal as a main driver, different application domains. And that resulted in also a good embedding of courses, universities picking up SystemC as part of their standard curriculum. So if a graduate comes from university, there is a big chance he has SystemC on his resume, which is a big plus.
So I have one data point. I checked the other day on LinkedIn, if you search for jobs in the US, and if you look for SystemVerilog, it has about 600 jobs openings currently, which is about what you maybe would expect. If you do SystemC, there's about 150. And if you look for high-level synthesis, there's about 60. And that kind of jives with what I would expect. But, you know, I think maybe SystemC and high-level synthesis are doing them better in the US than people are aware. The other thing is, if you look at those postings for SystemC and high-level synthesis, there's a lot of what I would consider to be the most bleeding-edge projects. They're like machine learning, 5G wireless, video. They're all the name brand companies. There's Apple, there's Qualcomm, there's Intel, there's Facebook, there's Google. They're out there. I mean, you know, you just have to look that the activity is out there.
So I'd make one other historical comment, which is from the standpoint of design and implementation using SystemC with high-level synthesis, where we saw the initial adoption was Japan, not in Europe primarily. And I've thought a lot over the last 20 years about why that might be. And my conclusion is that it has to do with what Stuart was talking about, catalysts. And at that time, the catalyst was the expansion of resolution of cameras. Our first adoption was of HLS with SystemC was in camera companies in Japan. And the expansion of the resolution created a requirement for higher speed processing of the images. And the feature set that was competitive in that space required more complex algorithms for recognizing faces and putting boxes around the faces in the picture when you hold up your camera. And let me tell you, as you move a camera around and it keeps tracking the faces in the boxes, there's a lot of multiplication going on. And that is impossible to do in the processor you can fit in a camera or maybe in any processor at that speed. And so they were driven to do this with a more dedicated hardware. The algorithms they had for this were in C, and so doing it with HLS and SystemC became natural.
But kind of coming back to what Martin was saying, actually I grew up in Europe, so I lived in the US for 20 years, so I can probably act as kind of mediator between the two. But definitely I see a big difference in terms of the government participation in the type of system level design projects and kind of the sponsoring, the types of projects which are written out in Europe compared to here. And also I think the curriculum is actually, I think, a big difference, a very big difference in terms of making it almost by default standard in the European curriculum. And actually, if I go back to my user base, I think one of the things I get asked most by customers is that, can you please bring us people who have the expertise? I almost act like a curriculum broker of bringing in people who have SystemC expertise. So there seems to be a disconnect between the amount of people available and kind of what the US curriculum really offers in the schooling. So I think if I go back to kind of the critical bottlenecks for adoption, what I see in my customer base, it's definitely availability of talent. So maybe it is time to solve that in the US.
So that brings up another good point. What activities should we as an industry, whether it be the EDA vendors or the users or Accellera, what things should the industry be doing to help further the adoption of SystemC, further the advancement of SystemC? What do you think the next steps need to be to really help SystemC achieve its full potential in the industry?
Well, if we go back to the theme of connection, I think that's an important part of the whole thing. So SystemC models cannot just stand in isolation. So you write some high-level models and you get it working, and now what, right? So you have to eventually turn that into silicon and software and the whole system. So in order to really make that work, in order to get more adoption and have people use it, although I don't think that's the end goal by itself, we need to be able to make sure that the language and the tools are connected in with RTL flows and with software development flows and so on. So building virtual platforms, which most companies do nowadays, and be able to drive software development, that's fine. But then we also need to connect that into RTL flows and emulators and FPGA boards and all that sort of stuff to build a complete flow that can move from those high-level designs all the way through to final implementation and physical design out the door, right? So I think that's a big part of it.
Yeah, just to echo that, I think it really needs to be part of that overall flow. I think if I see customers using SystemC today, it's mostly in the realm of virtual platforms and architecture design. It has to be an integral part of that mainstream design flow, so it's entombed in the design flow. And actually, I think if you create that, you will have a funnel over time that people will use it as kind of an abstraction layer. If it's not in that mainstream of design, I think it will always be kind of a little bit of an esoteric technology. If you look at virtual prototyping and platform or architecture design, rather, it really needs to be in the midstream of design and guaranteed because of that it's going to be used in every single project and has a long-term standing. And as Mark kind of indicated as well, I think we have some, and I fully agree with, is that I think we have some ways to go of making it part of the verification flow. and fully synergistically kind of make it part of the overall flow and make sure it's fully integrated, specifically on verification.
You know, I'd like to echo back to something that Mark said also, which is to take a step back from tools and languages and standards to observe that none of these things are in fact an end goal in themselves, other than paying my mortgage and a few little things like that, but that the purpose of all of this activity is to enable creative engineers to express their innovation in systems and semiconductors that improve people's lives around the world. I mean, in the big picture, that's what all of these standards are for. It's what all of the EDA tools are for. And I think that's a noble and valuable purpose to commit your effort to. At least that's what I tell my wife.
Yeah, one of the big challenges is with SystemC adoption is that SystemC is a language, is a standard, it's addressing the how. But I think the biggest challenge in interaction with design teams is answering the question, why do you think you need models? And what do you like to model? And also, what do you not like to model? So it all boils down to use cases. So do you want to make a virtual prototype for software development? Yes, then you have a certain abstraction level and a certain modeling style. If you want to do high-level synthesis, you have another type of abstraction, other type of modeling style. At the end of the day, it is all C++. SystemC only offers you a skeleton, which is giving you some notion of hardware and architecture context, but the actual functionality and behavior and the abstraction of it, that is what you have to write yourself. So that means a lot of discussion needs to happen before you start typing a letter of code. And since there are so many use cases, there might be some misinterpretations by management or by your fellow colleagues that no, SystemC cannot be used for that. I think then there might be a misunderstanding in, okay, what was the initial use case you were thinking about to make your models, and where are you using it for now? I think the advantage of existing languages, HDL and HVL languages, they have a rather tight and narrow scope in terms of how you should use them. SystemC, as said, is C++, so you can go in any direction, so you need to constrain yourself, and that is the initial discussion, why to model, what to model, and then how to model with SystemC. That might be an answer, but also might be not an answer, depending on what your objectives are.
And I guess that's also where part of the expertise comes in, right? Sometimes people say modeling is an art. I wouldn't agree fully with that, but there is some flavor to that. You really have to know what you're doing within the context of your set use case. And of course, SystemC just doesn't give you that automatically, right? You have to have some expertise and knowledge on modeling at a certain abstraction level, as Martin was indicating, and then fulfilling that use case.
Yeah, so you have to go through a learning curve, and what I've seen in Europe already for 2 decades is it all started with user groups. There were people coming together which were trying to learn, how do I use this language, how do I apply it? So we had a European SystemC user group, which was a very vibrant community. Actually, in India, we had similar type of groups. There was the Indian user group. In North America, we had those user groups. And they were quite successful, and Accellera saw that, and the Open SystemC initiative saw it, and they thought, hey, that's a nice thing. Let's bring it into the context of DVCon. So now the SystemC activities have found their way into a DVCon conference here in the US, but also in Europe, also in India. However, there is still this need where those engineers will come together and discuss, okay, what did you do with SystemC? What did work? What didn't work? And that is one of the reasons why in Europe we have now established the SystemC Evolution Day as a sort of user group 2.0 concept, where again the user community, which really like to learn from each other, understanding use cases, what is expected from the language in the future, that they come together. So in order to get a similar movement here in the US, my preference would be to see if we can install some of this user group concept or SystemC Evolution Day concept, where engineers from different companies just come together. And I think Accellera is willing to facilitate that where possible.
I think that also is an area, I think, where we as EDA providers can actually help more. One of the things I see happening with new customers is that their management jumps on the bandwagon and has heard about SystemC, but they don't realize all the needed expertise and kind of the abstraction level knowledge and kind of the deployment part you really need to have to basically make the best out of what you set to try to achieve. So I think even us as vendors, I think we have an obligation to help clean these flows and kind of lead the way and bake in a lot of the knowledge partially in the flow. Because at the end, SystemC plain on itself, it's just C++. It's not going to get you very far, right?
Yeah, I mean, one thing I think that Accellera can do, and maybe other organizations too, is provide some realistic examples that are sort of starting points for design and verification teams. And you know, as I said, I think the base Accellera standards are in good shape for SystemC. But if you want to build a virtual platform, if you want to build a hardware accelerator using HLS with some bus interconnect, there's not much out there available today. There's one recent thing that I've seen from NVIDIA is open sourcing a lot of virtual platform stuff and some HLS models that look pretty promising, I think. But there's very little out there in general that people can look at that's concrete. Because if you're in a design or verification team, you can't just say, you know, this looks really interesting, I want to go spend 6 months and learn it. You know, the way the project schedules work is you got to jump in and be productive and show results right away. And so that initial ramp up is very important.
It's easy to get yourself in trouble with SystemC, right? So it's just C code, as Martin pointed out, right? So all you need to get started is your favorite text editor and a C compiler, and you're off, right? There's nothing else. And if you don't have any methodology or place to start or examples or whatever, you can easily get yourself boxed into a corner. I've seen this happen, right? So where hardware engineers jump in and they start modeling things at the signal level, and next thing you know, they're writing RTL code in C++, and it doesn't really work out. So I think some more methodologies, perhaps some standards in that area, examples. The TLM standard, I think, is one part of that, right, showing how to build models that can interconnect with each other and have some shot at actually making them fit together. So more things along that area, I think, would be really helpful to get people into it so they don't get themselves in trouble and get a bad taste in their mouth from the experience.
I'll mention one thing that seems to be missing now, would be handy to have. In an HLS world, we want to verify our designs both pre-synthesis and post-synthesis. And right now, part of what's missing, there's been a lot of formal methods that have been effective in the RTL verification space. But we don't really have a good way to take assertions in the SystemC space and see if we can still check them in the RTL space. And in some cases, those assertions will fail because high-level synthesis is adding timing data. But there are other assertions that we could write and would be preserved and would also be hints for HLS tools to do a better job. So that's one piece I've seen missing.
So I do know at least one EDA tool that has that capability.
Hi, this is Horace from Microchips. I got a question about the how's the relationship of SystemC versus the C++. As you know, C++ has evolved quite a bit since SystemC has started as a standard, and there's a lot of new features in the new C++ standard that we love to use. And do you have any roadmap that you roll into the later C++ like language feature into SystemC anytime soon?
So you're looking for a SystemC roadmap for the future.
So the latest release, I believe, supports C++ 11, the 2.3.3, is that correct?
Yep.
And then I know that the IEEE committee is also, that's just kind of started up looking at the standard for the next revision, whatever that might be. They're also considering this as well, C++ 11/14, trying to utilize those features. So I don't know that there's a specific roadmap for that stuff, but that's definitely being talked about and being considered.
Yeah, and I'd also say that some of the answer to that question is for use of C++ 11 or 14 features inside the SystemC library, that should be largely invisible to a user, except to the extent that the capability of C++ 11 and 14 enables new capabilities that make the library easier to use or applicable for new tasks, et cetera. And so some of that is in the most recent Accellera libraries, and that's a trend that I expect to see. There's a lot of interest in that particular trend in the working groups, so I would expect to see that continue.
My name is Gaurav Bhatnagar from Analog Devices. So basically, I want to know what's going on in the analog space with respect to SystemC. what's going on in the mixed signal side and the analog side?
SystemC AMS standard was released, I think, 2 years, 2016, as IEEE standard. You might know that, IEEE 1666.1. In the meantime, the working group within Accellera is updating the user guide, so that is ongoing. We expect a release in the coming months. And as part of the, let's say, validation of proof of concepts or reference implementation, because Accellera, unlike SystemC, doesn't own the SystemC AMS reference implementation. There is an open source version made available by a startup company. In order to make sure that that standard is compliant, there is a regression test suite available, but that is currently only in use in the working group. And we are also planning to make that available. And of course, these are not the big industry examples, but in order to give also the community some feeling on, okay, how do you write code in SystemC AMS? What are the different models of computation which are supported? Because we are using a data flow engine under the hood, we have a linear solver under the hood, so that requires some new skills and examples. So that is all part of this regression suite, which will be probably somewhere in the second half, released in the second half of this year.
So do I have to walk down here to ask a question? Talk a little bit about why you use SystemC AMS.
That's probably what I was actually coming to. So I want to also add to it, like what are the advantages you see as compared to the, the traditional methods available by using SystemC AMS?
Yeah, the existing languages like Verilog AMS, I think there is a team working on System Verilog AMS, but that's not there yet. But Verilog AMS has some definitions in terms of how to synchronize between the analog and digital world. That's part of the standard, and I think that allows a very fine-grained synchronization and resolution mechanism. However, for fast or ultra-fast simulation, the synchronization mechanism is probably not so ideal. Meaning we reinvented the mechanism, how do you need to do synchronization, and also how do we deal with discrete events, because you might have seen quite some companies moving to real number modeling approaches, so mapping your real values, not on an analog solver, but in real values in a discrete event fashion. However, then you are, between quotes, misusing the discrete event engine because you're generating many events to follow your analog continuous waveform. So that's also not, let's say, a computational efficient approach. So for that reason, there is a data flow solver under the hood. So SystemC AMS has chosen fundamentally different simulator kernel concepts, including abstraction techniques, with the main reason to speed up simulation. And at the end of the day, it's all about abstraction, the trade-off between accuracy and simulation speed. That remains the case in SystemC AMS, but we have chosen slightly different kernel approaches and modeling techniques focusing on simulation speed performance.
Mm-hmm. Yeah, when actually I take a look back at the customer base, I think in general, Martin, I think the amount of people who ask us about SystemC AMS is very extremely low. So maybe a hint for the working group is to advocate the benefits more. Because today we basically see, anybody using SystemC AMS in the audience today? Yeah, so very low. So yeah, maybe advocation of the benefits would.
Yes, there is a lot of material out there, but of course the working group can write even more material. That's not not a problem.
Well, maybe Accellera needs to pick it up.
Yeah, this is a good point for Accellera. You're right.
I see a question coming from the audience right now.
Yeah, I'll bite on that one. I probably should be using SystemC AMS, but I'm wondering, is there a path to go from a data flow model of a SystemC AMS model and put it on an FPGA?
Should we start from the modeling side or should we start from the synthesis side? I think there were discussions in the past because since this is a data flow graph, it is, let's say, computed prior to simulation. So statically it is known. So I think there is an opportunity that those statically scheduled graphs are excellent starting point for synthesis in any direction.
Hi, Tan Lee from Teradyne. Over 10 years ago, before the OVM came out, we pretty much used SystemC for constrained random, but then the OVM and UVM came out, it's pretty much pushed the SystemC use model on the side, and then since then, I think at least my companies invest so much time, environment, train people, infrastructure in place. So right now, it's all in UVM world right now. To get back to SystemC, I don't see how that's possible unless the SystemC somehow and the vendor maybe need to talk more about it. I know in about 8 years ago, we virtually, I didn't hear any vendor talking about the SystemC at all for the verification side, right? Certainly, I kind of surprised to hear the SystemC come back again when they come back here. So I don't know what is the plan is there any plan to transition from the SystemC flow to the UVM? Hopefully there's a connection there to verification side. Otherwise, I don't see how can I throw away all my 10 years investment on UVM and trying to see how I can integrate that into SystemC.
So I'll take that real quickly. I mean, the typical usage that we see today is if people are doing constrained random and sequences and things like this, even functional coverage, they do that in UVM System Verilog, and then they can still integrate that with multi-language simulation support to drive SystemC models. And that's probably the most typical usage right now. And I know that there's work underway on UVM SystemC. I was involved many years ago in some of the SystemC verification stuff. I'll just say that there's a massive investment, as you say, in the System Verilog verification infrastructure and constraint solvers and also things that people forget about, like debugging constraint solving failures that you don't necessarily want to run. I mean, maybe we can replicate that on the SystemC side, but you shouldn't underestimate the level of investment that's needed to bring that up to where the System Verilog already is.
I think, if I could just comment, I think one of the issues is differentiating between unit level verification and system level verification. Right, so at the unit level, probably your UVM flows is where you want to go with that, right? At system level, where you want to incorporate software and you have things that are much larger than might fit on your workstation or your server, SystemC might be of value there to help you build test benches or frameworks that you can drive with your application software or tests that use part of your application software. So I think that distinction is probably going to be helpful to think about it.
I also see the situation where the implementation is being done in SystemC and using HLS, and as a result, trying to use the same techniques that are in UVM in System Verilog, using those in SystemC, has a synergy because the data types and the interfaces are already defined, and you already have the design in SystemC, and so there's a synergy of doing at least, in this case, he says the block level verification using UVM approach, but in SystemC to stay close to the implementation for the folks that are using SystemC and HLS as their implementation flow.
Hi, my name is Fred from Facebook. Thanks for the great panel so far. It's been demonstrated many times the benefits of SystemC and HLS for design. And we went from 3 major vendors to 2 major vendors recently. And there's some C flows, there's some SystemC flows with different names for the pragmas or directives and different meaning for the channels and things like that. Any observations how we can unify these flows to energize the marketplace and maybe have a third vendor or more SystemC alternatives?
Well, I don't know how we can answer getting a third vendor. I think, Fred and I are good friends, so I know where he's going with this. But I think that there's already been quite a bit of unification. Now, we're not at the point yet where you could take any arbitrary HLS design and run it on either of the 2 major HLS flows without some tweaking. But we've come a long ways. We have a good SystemC synthesis standard that's well supported by the 2 major tools. And the conceptual model that both the tools use for synthesis is basically equivalent. And I don't think it's, in terms of the skill set, moving a user or a set of designs from one to the other, I don't think it's that hard. It's not zero work. And I think getting it to the point where it'd be zero work is just going to take time.
I think that's a role that users can play. right? So by working with your vendors to say, well, I need this to work here and I need this to work there, and making sure that it all works together. Do you see what I mean? The vendors by themselves are not motivated to do this. So that I think the users will need to kind of force the issue with your respective vendors.
We also have, speaking as one of the vendors, we have the situation where each vendor has plumbed specific mechanisms for hooking the constraints or the directives into the tool, and those are quite different. And so it's not only a question of defining what is the semantic for unroll this loop, which is well understood and pretty common. It is, how do you express that, and how does that then get hooked into the synthesis process? So it's a bunch of work, worthwhile work to do. I think that's a good.
I think it needs to be done, but I want to emphasize one thing, which is, you know, when System Verilog first came out, the System Verilog was not transportable between different simulators. It took a long time, right? And people could say that System Verilog was a failure in the early years, but you miss the point that just because the language was similar and people could learn how to use System Verilog and UVM, and those learnings were applicable across tools, was a major benefit. And I think that's basically where we are right now with System C for HLS.
So in that case, UVM was kind of the forcing function, right? So all the vendors wanted to support it, and so that became the medium to use to do that. So I don't know if anything like that would appear in the HLS space, but that's what you need, is something like that all the vendors then could align to.
And to comment on the comment of Mark related to, okay, how do you challenge your favorite vendor or vendors? I think team up, not only in your own company, but also in other user companies, because if you say, I like to do this in System C, then your vendor might say, well, perhaps you should use UVM, or perhaps you should use System Verilog. I think you should form, let's say, a community and approach this a bit in as a common strategy, and move with some additional people into such a discussion to make sure that voices are heard. I think that's what we also do in Europe, is that we try to team up and to understand, okay, is this indeed, what is the right language for the job? And we try to consolidate our user requirements. And that's actually also what happens in Accellera working groups, right? I think there are different organizations with different background, different business models in mind. That's all understood. But at the end, we have to come to a common understanding and a common standardization. And I think there Accellera can also facilitate.
And I have to say, if you want that to happen, come join the working group, sit in the meetings, listen on the phone, and make your voice heard. This is how this gets done. And in an Accellera working group where there are, for I think any of the standards, where there are both vendors and users present, the users have a forum to express their requirements in a way that cannot be ignored, and in a way that is influential in the roadmaps of all the companies. So if you have interest in seeing those kinds of changes, show up for the working group meetings. That's an outstanding way to contribute.
Yeah. It's an easy way of having impact, for sure. Yeah.
Well, I can certainly vouch that as an analyst at Pedestal Research and at which was previously Gary Smith EDA, we have been huge proponents of the shift toward working at the system level, at designing and verifying at the system level. We've been talking about that for many, many years. And clearly here, everyone on this panel is a huge evangelist for that type of a methodology as well. One of the challenges has clearly been over these years to make sure that all the users are also on that same page and see the benefits and see what the pain of shifting their current methodologies to a system level viewpoint, what it can do for them. So I was going to ask in closing here if there are any kind of, I don't know, case studies or specific examples that our panelists have seen for what going through that kind of a painful process in changing how you do your design and verification, what that can really mean for a user of that methodology.
So what I've seen in NXP is that SystemC is used for different use cases, as I mentioned before. So software development, and also with our customers. So we deliver a semiconductor company, obviously, to the tier ones in this industry, and you see that there is a good interaction when it comes to that they can use our products and develop the software stack. That's one use case which is very successful. Another use case, I think there was a remark made on SystemC AMS is not well understood or well adopted, deployed. I think it is in use in production in NXP. We make mixed signal ASICs and primarily use it for architectural explorations. And these are automotive products which require serious analysis of statistical corner cases at the Monte Carlo level, and how are you going to do that at the transistor level? You can simply not do it. You have to move it up to the system level, and you need to get results in a few days and not in a few months. So there it has been shown that we can really use this type of system level mixed signal languages to really explore architectural exploration of mixed signal chips, which have never been done before. I think there are even some publications on that given in previous DVCons. So that are clear proof points that there is added value of SystemC. But yes, we have to acknowledge the learning curve. We have to acknowledge that sometimes tools capabilities may lag behind of user demand and user request. So you need to be inventive to sometimes compile your own library into a commercial flow, but that's live and that's also fun, actually. And then you can get the best of all worlds. You get a commercial platform of your EDA tool, but complement it with your own libraries in order to do sophisticated modeling.
So at my company, I don't know, 2-3 years ago, we undertook the task of replacing an in-house cycle-based simulator, cycle-accurate simulator with SystemC. And I would say the transition probably took the better part of 1.5 to 2 years. It wasn't instantaneous. It took us a while. Probably there was probably a couple challenges. One was getting all the engineers up to speed on SystemC. They all knew C++, so that was a good start. The other challenge was explaining to them that they don't need clocks anymore. So
Can't clock yourself to death anymore.
this was I think still an ongoing challenge. They still get that all the time. Well, we got to have the clocks. So I think that was the biggest challenge.
Yeah, having been in a startup, it's always kind of looking back the last 20 years, how long it took for virtual prototyping, specifically for the software use case, how long that took to get commonly accepted. I mean, in the early days, just asking about SystemC and virtual prototyping, I still remember the heated arguments with engineers and even managers about the fact that you needed to be cycle accurate to even be able to run software. I mean, that's all past us. But just the efforts which goes into getting a flow commonly accepted, and there's a whole plethora of different facets to that. There has to be the language support, there has to be examples out there, there has to be advocation, which can be done, for instance, by EDA vendors like ourselves. I mean, for instance, for virtual prototyping, we did compose a book targeting management on the benefits and how you deploy these things. It was basically customers talking about their experiences, but it's always a surprise how much goes into making something a common flow and a well-accepted flow. And I think this is also, I think, where you can contribute. For instance, Mark publishes a lot of articles about reusing SystemC for verification. Through these channels like the user communities of Synopsys or other vendors, I think you can also have an impact. But it takes a lot of time before something is commonly accepted and fully supported in the industry. So always looking back the last 20 years, how long it takes.
So I think all of these use models have a common theme, which is not how can I use SystemC. That's not a goal in itself, but how can I express my design intent at higher levels of abstraction? That's true in expressing my system intent at a higher level of abstraction using SystemC, and for expressing my module level intent, design intent at a higher level of abstraction. And I think always the advantages of expressing your intent at a higher level of abstraction are that you can start to test whether your intent meets the needs more early, so verification earlier, and that you have committed fewer of your decisions into stone, and so you can change your decisions later. I think that's true for system level modeling. I think that's true for implementation using HLS. All of these are about expressing your intent at a higher level of abstraction. And third is that you can figure out what you broke more easily when it's at a higher level of abstraction. If it's not working the way you want it to work, you can figure that out a lot more easily if there's fewer lines of code and fewer processes and fewer things going on in the model itself. You can debug it more easily. So I think all of those things are about raising the level of abstraction at which you do your design work.
Yeah, I think I'll just echo mainly what the other people have said, but in my experience with these very complex designs, if you had to summarize where the real problems were, it's in integration, right? When all the pieces finally come together, that's when you find all the problems. And typically for these really complicated designs, that's in emulation. And the advantage of moving to a system level flow and using SystemC and high level synthesis and virtual platforms and so forth is that you can find many more of those problems much earlier in the design flow and debug them at a higher level of abstraction. And that's the real payoff.
Well, I want to thank you all for coming to this panel and the very lively conversation. Stuart, Mike, Philip, Mark, and Martin drove here. I think they were very enlightening, and they gave us lots of action items to come away with from here. Very specific things that users can do to up their game, that Accellera can do to help connect users to the standard and to each other, and all kinds of things that we can be thinking about as a community to further the cause and make design and verification an easier process that is a more successful process in the end to develop all the complex products that we all need in our communities. So again, thank you very much and enjoy the rest of the conference.